So welcome to this session on binomial theorem. Here we will discuss binomial theorem and a few applications. So we start with a plus b the whole squared, you know, is a squared plus 2ab plus b squared. A plus b the whole cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. So if you take the coefficients of a plus b the whole squared, you have 1, 2, 1, and we start with 1. So we write 1, 1 here, and 1 plus 1 is 2. So this is the coefficient of a squared plus 2ab plus b squared. So again the next row we write the first entry as 1, next entry as 1, and we add 1 and 1, you get 2. So this is 1, 2, 1, which is the coefficient of a plus b the whole squared. If we continue and add 1 plus 2, 3, 2 plus 1, 3, we add two consecutive terms here. 1 plus 2 is 3, and then 2 plus 1 will give you 3 here. So we get a plus b the whole squared. And here if you add 1 plus 2 is 3, 2 plus 1 will give you 3. So this is the expansion of a plus b the whole cubed. So this is called Pascal's triangle, where you have 1, 1, then 1, 2, 1, 1, 3, 3, and so on. How do you get it? Just keep adding. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3. Now a plus b whole raised to n, if n is a positive integer, the expansion is given by a raised to n plus nc1 a raised to n minus 1 into b plus nc2 a raised to n minus 2 into b squared up to b raised to n, where nc1, nc2, and nc3 are called binomial coefficients. So we start with a raised to n, then we write an nc1, the power of a reduces each time, and we introduce a b. So the power of a keeps on reducing, power of b keeps on increasing till we get b raised to n. The number of terms of a plus b whole raised to n is n plus 1. And this is another useful thing to remember. A plus b whole raised to n plus a plus b minus plus a minus b whole raised to n. If n is odd, the number of terms in a plus b whole raised to n is n plus 1 by 2. If n is even, a plus b whole raised to n plus a minus b whole raised to n has n by 2 plus 1 terms, and a plus b whole raised to n minus a minus b whole raised to n has n by 2 terms. You can actually take elements like start with n is 4 or 2 and check it out. Whereas if n is odd, both a plus b plus raised to n and plus or minus a minus b whole raised to n has n plus 1 by 2 terms. So we start with a few problems. Find the number of terms in 3x minus 7 by y squared raised to 8. Now number of terms in a plus b whole raised to n is n plus 1. So number of terms is 9. We have seen that here. Number of terms in a plus b whole raised to n is n plus 1. Then find the number of terms in 1 plus 2x plus x squared whole raised to 7. What is 1 plus 2x plus x squared? It is 1 plus x the whole squared raised to 7, that is 1 plus x raised to 14. So what number of terms is 15. Find the number of terms in 1 plus 3x plus 3x squared up to x cubed. So this is the expansion of 1 plus x the whole cubed raised to 5, which is 1 plus x raised to 15. So number of terms is 16. Now if I take 2x plus 3y raised to 49 plus 2x minus 3y raised to 49, going back to your formula, if n is odd, number of terms is n plus 1 by 2. 49 is odd, so number of terms is 49 plus 1 by 2, which is 25. Again, find the number of terms in root 3 plus 5x squared raised to 93 minus root 3 minus 5x squared raised to 93. N is odd, so number of terms is n plus 1 by 2, that is 93 plus 1 by 2, which is 47. What about 4x squared plus 5 root 3y raised to 100 plus 4x squared minus 5 root 3y raised to 100? N is even, and when n is even, a plus b whole raised to n plus a minus b whole raised to n has n by 2 plus 1 terms. So number of terms will be 100 by 2 plus 1, which is 51 terms. Then we have 1 plus 7 root 2x raised to 50 minus 1 minus 7 root 2x raised to 50. Again, what's the formula? If n is even, The number of terms in a plus b whole raised to n minus a minus b whole raised to n is n by 2. So what is the number of terms here? 50 by 2, which is 25. So these are useful formulae to remember as objective questions. Now coming to questions, expand 2x by 3 minus 3 by 2x raised to 4. So we have the expansion for a plus b whole raised to n. We are not going to remember one more formula for a minus b, just write it as plus minus. So your a is 2x by 3 and b is minus 3 by 2x. So this becomes 2x by 3 raised to 4 plus 4c1 2x by 3 cubed into b, which is minus 3 by 2x, plus 4c2 2x by 3 squared minus 3 by 2x squared. So the power of 2x by 3 reduces, the power of minus 3 by 2x increases. And subsequently you have 4c1, 4c2 and so on. Then I have 4c2 2x by 3 minus into minus 3 by 2x cubed. And lastly, you get 4c4, which is 1, and minus 3 by 2x raised to 4. So the moment you get 4c4, you know you have come to the last term. So now if you simplify, you get 16 by 81 x raised to 4 plus 4 into 8x cubed by 27 into minus 3 by 2x. 4c2 is 6. 6 into 4x squared by 9 into 9 by 4x squared plus 4c3 is 4 into 2x by 3 into minus 27 by 8x cubed plus 81 by 16x raised to 4. So when you simplify, this is what you get. 16 by 81 x raised to 4 minus 16 by 9x squared plus 6 minus 9 by x squared plus 81 by 16 x raised to 4. Next question, expand x by 3 plus 1 by x raised to 5. So this is again a plus b raised to n, x by 3 raised to 5 plus 5c1, power of x by 3 reduces, x by 3 raised to 4, we introduce 1 by x, plus 5c2, x by 3 cubed, power of 1 by x increases, 1 by x the whole squared, plus 5c3, x by 3 squared, 1 by x cubed, plus 5c4 x by 3 into 1 by x raised to 4, and the moment you reach 5c5, just write 1 by x raised to 5. So simplifying, you get this as x raised to 5 by 243 plus 5 by 81 x cubed plus 10 by 27x plus 10 by 9 into 1 by x plus 5 by 3x cubed plus 1 by x raised to 5. Now use binomial theorem to evaluate this. So don't use the calculator since they have asked you to use binomial theorem. We write 96 as 100 minus 4. So this is 100 plus minus 4 cubed. That is 100 cubed minus 3c1 into 100 squared. The power of 4 starts increasing into 4 plus 3c2 into 100 into 4 squared minus 3c3 and you write 4 cubed. The moment you reach 3c3, you write 4 cubed. It's useful to remember that when you have minus, you write alternate plus and minus. So this is 100 cube minus 3 into 100 squared raised to 4 plus 3 into 100 into 16 minus 64, which is 8,84,736. Next, expand 10.1 raised to 4. So 10.1 raised to 4 you can write as 10 plus 0.1 raised to 4. So again use binomial theorem, it is 10 raised to 4 plus 4c1, you keep on writing 4c1, 4c2 into 10 cubed into 0.1 plus 4c2 10 squared into 0.1 squared plus 4c3 10 into 0.1 cubed plus 0.1 raised to 4. So when you simplify, this is what you get. You can use the calculator for simplification. Now expand 102 raised to 5. 102 raised to 5 you can write as 100 plus 2 raised to 5. That is 100 raised to 5 plus 5c1, power of 100 reduces. 100 raised to 4 into 2 plus 5c2 100 cubed into 2 squared plus 5c3 100 squared into 2 cubed plus 5c4 100 into 2 raised to 4 plus 2 raised to 5, and finally when you simplify, I want you to calculate the answer and write it down. Next, 0.99 raised to 5. So again I can write this as 1 minus 0.01 raised to 5. So again we write it as 1 raised to 5, which is 1, alternate plus and minus, minus 5c1. Now here you are just asked to expand it up to 3 terms. So I just write 3 terms, minus 5c1, 1 raised to 4 into 0.01 plus 5c2, 1 cubed into 0.01 squared, and you get the answer as 0.951, because the problem is just to expand it up to 3 terms. So you can just make a note of it. We just expand it up to 3 terms. Okay, next we go to use binomial theorem to evaluate root 3 plus root 2 cubed plus root 3 minus root 2 cubed. So we are expanding the same thing, but one with a plus and one with a minus. So we just put alternate plus and minus once you expand the first term. So you get root 3 cubed plus 3c1 root 3 squared. The power of root 2 keeps increasing into root 2 plus 3c2 root 3 into root 2 squared plus root 2 cubed, and then you just write the same thing with alternate plus and minus. Root 3 cubed minus 3c1 root 3 squared into root 2 plus 3c2 root 3 into root 2 squared minus root 2 cubed. So you can see that these terms get cancelled, the other terms are repeated. So you get 2 into root 3 cubed plus 3c2 is 3 root 3 into root 2 squared. So root 3 cubed is 3 root 3, root 2 squared is 2, so you get plus 6 root 3, you get the final answer as 18 root 3. So thank you for watching and stay tuned in to my next session on binomial theorem. Thank you.